So top-down parsing is nothing but in this method we need to create the parse tree starting at the root and creating the nodes of the parse tree in pre-order. So DFS method and then parse it. So it is also can be viewed as finding leftmost derivation for an input string. Okay, so if I have this grammar, I will write the non-recursive one only. E gives te dash, e dash gives plus te dash or epsilon. Then t gives ft dash, t dash gives star ft dash or epsilon. Then f gives id. Okay, you need to remember this grammar, or you remember in this way e gives e plus t in that way, and then remove it for top-down passing, the recursion. Anything is fine, because sometimes in the questions they will just mention that use arithmetic expression grammar and then solve the problem. Okay, something like that they will use. So you need to know the grammar. Every time they need not give this grammar. Okay. So if you take this, top-down parsing will start always with E. So if I have input string ID plus ID star ID, then how do you construct the parse tree? We will see how. I hope everybody remembers how it is. So it's a leftmost derivation. So all of you derive leftmost derivation for the string quickly. So it is E. This is LMD, because top-down parser uses leftmost derivation. So always we start with and also the construction of parse tree is starting from root to the nodes. Okay, so from root it derives. So from E, te dash, so t is replaced with ft dash e dash, f is replaced with id, t dash e dash. Next, t dash should be replaced with star ft dash or epsilon.
Epsilon.
Yeah, so epsilon e dash, then you get id. E dash is replaced with plus te dash. Then you get id plus t is replaced with ft dash e dash as it is. Then you replace this f with id, t dash e dash. Then you have t dash should be replaced with, I need to get star id, right? So I go for star ft dash and e dash as it is. Then I get id plus id star, f is replaced with id, t dash e dash. Since both t dash and e dash can derive epsilon, I have all my input string in this. So I replace t dash and e dash with epsilon. So it's one more epsilon. So I get id plus id star id. So in the same way, it constructs the parse tree. Like if you give te dash, I hope you can construct it, because for each sentential form, you need to have one parse tree step. So t dash, t is replaced with f t dash, right? So it continues till you get id plus id star id. Okay, so there is a confusion when we go for the productions of e dash and t dash, right? Because I have two productions, whether to go with plus te dash or epsilon or star ft dash or epsilon for t dash is a question. Here we are deriving by hand, so we know, looking at the input string, we know we want star here, we want plus here. Now how do you code that into the parser as a question, right? So it has to construct this parsing tree without any ambiguities. Now a general, so what we do when a parsing has to be done or a parsing tree has to be constructed, at each step, the top-down parser should um, go through two key problems. One is determining which production to be applied for a non-terminal, say A. Okay, in this case, E dash or D dash. Once a production is chosen, the rest of the parsing process consists of matching the terminals with the input string. Okay, terminal symbols in the production body of the production, and then with the input string. It keeps matching and then continues. Okay, so a general form of top-down parsing is called as recursive descent parsing. Okay, recursive descent parsing is a general type of top-down parsing wherein you don't have lookaheads. It can just read the current symbol and applies the, we will see also the pseudocode for this, applies the productions from that non-terminal, tries to match the input string with the body of the production for that non-terminal. Okay, this is the first type of top-down parsing, which is a general one. A special case of recursive descent parsing, wherein we have which chooses the correct production by looking ahead at the input, a fixed number of symbols. Typically, we look for one symbol. Okay, so that it's definite. Okay, so because recursive descent parsing is indefinite, it randomly chooses between the productions when we have more than one production for a particular non-terminal. But in a predictive parsing, predictive parser or parsing. Okay, in predictive parsing, it definitely chooses one of the two productions, which one to go with for by looking at one input symbol ahead. Okay, so we will see a pseudocode for recursive descent parsing first, and then what are the advantages or disadvantages with this parser. Then we go with predictive parsing method. Okay. So pseudocode for recursive descent parsing. So the problem here is whenever a parser is trying to construct the parsing tree, the key problem, as I said, it has to choose the non-terminal to replace, and then once it has chosen, what it does is it tries to choosing is always leftmost, so it has to choose the correct production from this particular non-terminal, and then what it does is it tries to match the body of the production with the input string. Okay, so we will write for a non-terminal what it does. So recursively, it keeps calling the function and it tries to match the input string. Okay, if A is a non-terminal, then you have this pseudocode for each non-terminal. Okay, what you have to do, you have to choose a production or an A production, which is of the form A gives x1, x2, x3, xk. Okay. Once you choose the production, what do? For I is equal to 1 to k. Okay, 1 to k, 1 to k. What you're supposed to do? If xi, this xi in the body of the production, it could be a non-terminal or it could be a non-terminal or it could be a terminal. Okay, so we have to have three cases. If it is non-terminal, what it should do. If it is terminal, what it should do. If none of them is matching, then what it should do. Right? So if xi is a non-terminal, Okay, so what it should do if in this case, okay, so E it has already chosen, so this
Ma'am,
function is
this is
getting
for
executed for E.
recursive descent parsing, right?
Yes, yes.
Yes.
Hmm. So every non-terminal, I'm going to execute this function, right? So for E, if suppose I'm executing this function and I have chosen TE dash because there is no other production for me. So it has chosen the production. So this is X1 and this is X2. Okay. So for I is equal to 1 to K, so 1 to 2, what I have to do? I have to go with this for loop, right? So if Xi is a non-terminal, so T is a non-terminal now. So it matches with this. So what it should do? It will again call this function because it's a non-terminal, right? So we call procedure Xi. Okay. Calls this procedure back for every non-terminal. Suppose if it's a non-terminal as in this case, okay, if xi is, sorry, if xi is a terminal, then if xi is a
Should
terminal,
match
then
with the first string.
yes.
If it
So
matches, then
if it matches, it assumes that it matches. Okay, so if at all, if it is a terminal, then I have done a proper one in like in this case. Okay, so once it is matched, you have to move the input pointer to read the next symbol in the string. So advance the, it doesn't consider non-matching case. Now we are considering in else if it matches. So if it is matching, then what it's supposed to do, it should move the input pointer to the next symbol. Else, if it is not matching, so I have star here and input pointer is pointing to ID. Then what has happened? It says it's an error. Okay, for every non-terminal, it has to call this procedure. Now, in recursive descent parsing program, for every non-terminal, we do this starting with the start symbol always. Okay, but it is non-deterministic. Why it is non-deterministic? Because whenever I am executing this procedure for E dash, it may choose this production to go with, or it may choose this production to go with. There is no uh, always it says that only one production, right? It doesn't say what to do with the other production. Okay, so we cannot choose a unique production with respect to this, what it is saying here, because I have to be deterministic to choose one of the productions and two to derive at that input string, but I'm not clear at this moment, right? So it doesn't say anything. So a lot of things for example, if you take this simple grammar, I'll show you how it constructs the parse tree. This is a longer one. So if I take this, so this procedure doesn't say that I have to remove left recursion, left factoring has to be done. Nothing is there. Okay, this is a straightaway grammar. Okay, so what it does is if I give the input string as CAD, now the input pointer is pointing to C. The start symbol is S. Okay, so it calls this procedure. So from S, it chooses only one production is there. So choose S production here with respect to this algorithm. So it is C, A, D. Okay. Now once this is done, since the input pointer is pointing to C, when it comes here with respect to this, C is matched. So the input pointer is pointing to, it is advanced to read the next character in the input string. Now, what is there next here? It's a non-terminal. So with respect to this, it has to call the procedure for A. Now, when it comes to calling the procedure for A, you have two productions. Okay, so randomly it chooses for the first one because there is no unique choice for production for a non-terminal is defined here. So it goes to the first production. So what happens? C is already matched. Now we are writing for A. So this is how the parse tree is constructed. Okay. Now the input pointer is there at A. Now A has come. So this is matched with respect to this one. It has to advance the input pointer to read D. Now what is there next here? So if you follow the depth first search, so it has to read B. Now here it is B and here it is D. So error has occurred. Okay. That doesn't mean that from this particular grammar, this string cannot be generated. It can be generated. We can see here. But how do you make sure with this algorithm, we cannot say that it can be generated because after using AB, I cannot generate this string. So it realizes that using AB, I cannot. Let me try with the other one. So I have to do the modification here. Instead of having else error has occurred, what I have to do? I have to say, go and choose the next production for A, another production for A. So if to do that, couple of things I have to do. What I have to do? To, to be able to choose the next production and to match with the input strings because the input pointer is already moved to D. So even if I change the production and try to replace A with A instead of AB, then my input pointer is at D. So another modification which I have to do to this algorithm to be able to choose
Can
the
we
other.
retract and then
Huh. Retract means what? I have to store the input pointer value somewhere, right? Every time I move, I have to keep storing it. Otherwise, I can't go to that position back. That is what is retracting. So backtracking, that is what we say. Okay, so we have to keep storing the input pointer for future use in a local variable so that I can go back and choose this production and construct my tree properly. So what it does is it has to go back and say change this to A. Okay, choose this production A. So now again the input pointer should be pointing to this position. It matches with A. Move the pointer, which matches with the D, and then we say end. So end marker is usually highlighted with a dollar. Okay, it is right end marker or the input end marker. So once we reach dollar, we say the input is over. The string is derivable from this grammar. Okay, all those things are necessary changes for this general recursive descent passing code.
Is there left factoring here? Like AB and A is there.
It's there,
So
but it doesn't say that you have to remove it. Okay, this general parsing method doesn't say it. Only the predictive parsing method we have to take care of all of them to avoid this kind of
okay.
situation. Okay, so the first one
Ma'am,
we came up with the
uh,
general idea. Hmm.
like, is the pointer pointing to the string that is W, or is it pointing to the
W is the
production?
string. No. W
Like,
is the string.
like the pointer should be pointing to the production, or it should be pointing to the string, is what my doubt is.
No. Input pointer will be there. Input pointer is a different thing. And when you traverse this tree, it's a different thing. Two pointers has to be there, right? So you should point here and both of them should keep matching it.
Okay. Alright.
Okay, input pointer always points to the string, like in lexical analyzer, you have input pointer, right? So begin and forward pointer like that. You have two pointers here. One is for when you are searching this tree,
No,
traverse.
like the pointer which is like you have written below the W some arrow marks, right? So they're not this X1, X2, X3 and all, right? So the X1, X2, X3 all are like the production of CAD.
Yeah. Here,
So
X1,
like I
X2,
just got
yes.
confused like between the pointer of the production and the input pointer.
No, there has to be two, right? Otherwise, you
Yeah,
can't
yes, ma'am. Yeah, that's
match it.
what. Like for matching, we need two pointers.
Yeah, it
But
has to have two pointers. Okay, so a special case of recursive descent parsing is a predictive parsing, wherein what we do is, if suppose I have ability when I'm reading A, what is the next input? What is the string which is there next before choosing an A production? Then I can say, okay, don't choose AB, choose only A. Okay, then I can avoid this kind of situation. I need not have a backtracking because it requires, this is a very simple grammar, because for a language, if you go, you have many constructs, right? So it is very time consuming. You have to keep on storing the input pointer values so that it can be again restored back if there is a mismatch in the production choice. Okay, so that is not realistic. So always we go with predictive parsing method, even if it is there in production. We go with top-down parsing, means predictive parsing only, so that a definite thing is there from a non-terminal which production to choose. If the input symbol is this and the look ahead is this. Okay, so we go with predictive parsing always, right? So before going to predictive parsing, how we are able to see the, if the current symbol is this and the next input symbol is this, then which production to choose from this non-terminal, how we are able to do that, right? We construct a parsing table wherein we, for each non-terminal, if the current symbol is this, if the next input symbol is this, look head is this, go with this production. We have to be very definite for that. To do that, to construct the parsing tree, we need two types of set of terminals from the given grammar. We have to create that. That is, one is first set and the second one is follow set. So before starting the predictive parsing, we have to see how to construct first set and follow set. Okay.